on private sector participation in BOT project of Magong 5,500-ton desalination plant. Penghu County is an offshore island with poor natural conditions. The lack of natural water resources affects the sourcing of city water, resulting in livelihood water source deficiency, which causes inconvenience in the daily lives of Penghu residents. Penghu has a flat terrain that lacks rivers and mountains, and a climate model in which annual precipitation is far lower than the amount of total evaporation. Reservoirs have a small watershed and a short rainwater collection time. In a dry year that lacks plentiful rainfall, reservoirs run low with insufficient water storage, and water shortages are likely to occur. For a comprehensive development of offshore islands aiming to improve water quality for residents' daily use, as well as for corresponding to the increase of water demand resulting from tourism developments, it was a priority mission for the Taiwan Water Corporation to explore more water sources and expand city water facilities to provide an adequate supply of quality city water when the original facilities are at full capacity for both water production and water distribution. Desalination plants have become an emerging water resource, equally important to traditional water sources in many developed coastal countries, offering an effective solution to mitigate or eliminate the unbalanced supply and demand. In order to resolve the present insufficient water supply in the Penghu area, the Taiwan Water Corporation decided to build the BOT project of Magong 5,500 CMD desalination plant to stabilize the water supply by way of desalination, increasing the amount of clean water and capability to regulate the supply corresponding to quality fluctuations in the source water. Putting aside cost considerations, for enhancing throughput and water quality, Chinfu Water Resource Company Limited, a participant of the project, selected one of the first-class desalination systems in the world, which included a UF filter as the pre-treatment of seawater desalination, thus offering a steady yield. This will stabilize the water supply in the Penghu area, providing a safety standby load and achieving smooth deployment of the source water in the area as well. Located at Magong City of Penghu County, the project covered both the Magong plant and Wangan plant. A new 5,500 CMD system was constructed at the Magong plant, together with the refurbishment of a 7,000 CMD system, totaling a production of over 10,000 tons of potable water a day. A 400 CMD system was refurbished at the Wangan plant, providing 400 tons a day. Since Penghu has special geological and climatic conditions, the project faced multiple challenges in its execution. The Penghu Islands, including the plant area, are comprised of a basalt formation that is hard and rigid. When excavating the foundation, there was only 1 to 2 meters of topsoil propped up by basalt underneath. The excavation was therefore mainly carried out by breakers in combination with power shovels. Since the plant area has a shallow seafront, working barges for laying the seawater piping were unable to approach the seashore. A cofferdam extending 250 meters into the outer sea had to be built so as to utilize the ebb tides 2 times a day, during which the seawater within the cofferdam was pumped out with pumps in order for the construction machines to carry out excavation on the seabed. By high tide, the machines were again withdrawn ashore, thus cycling the excavation work. The offshore location for laying the water intake structure was first excavated by excavating machines that were carried by a barge to the location. Then, the intake structure was carried by the barge from the wharf to the installation location, where it was connected to the water intake pipe, 1 meter in diameter and 320 meters in length, and sunk into the seabed. A brine water discharge pipe with a diameter of 900 millimeters and a length of 1,200 meters was laid extending offshore. All maritime works were carried out with protecting marine ecology the first priority. In order to minimize the damage to tidal flats and rocky reefs on the south side of the plant, the excavation work was kept to a minimum. To prevent the pipeline from being struck by wave breaks at the tidal flat, a duct was excavated to accommodate the pipeline. After laying the pipeline, the duct was grouted with high-strength concrete to protect the pipeline, followed by replacement of the surface sandstone originally excavated from the site, so as to restore the original terrain of the seashore. The pipeline underneath the tidal flat was anchored with concrete blocks to minimize disturbance to the seabed formation. In the aspect of cultural legacies, archaeological findings and antiques discovered within the excavation area were all handled in accordance with relevant regulations of the Cultural Legacy Preservation Act. The Chunful team retained an archaeology team led by Professor Liu Yi Chang of the Academia Sinica and Professor Pan Yinghai of National Jinan University to carry out an archaeological survey at the site of foundation excavation and underwater pipeline laying. Upon finding a grave like this, we made preliminary verifications based on cultural legacy standings. We judged it was a burial site from a period between the end of the Qing dynasty and the Japanese occupation. Therefore, not a cultural legacy of significant value, and we suggested the customary treatment. With the process of cultural legacy, we stopped, recorded, made survey and graphs, so that people understood that we did not destroy any cultural asset or antique of folkloric value during the process of constructing the desalination plant. A compact spatial design based on optimal land use provides a smooth and convenient process sequence, as well as flexible scalability in the future, making extensive use of existing facilities and natural terrain conditions for accomplishing the most economical desalination plant on Penghu Island. The project consists of the construction of a 5,500 CMD water intake pipeline, a brine water discharge pipe, a desalination and filter tank, UF equipment room, sedimentation and regulation tank, water intake wells, and a pump room. The refurbishment of the 7,000 CMD treatment plant included a first RO room and a second RO room, the addition of a 2-story operation building, and the refurbishment of a 400 CMD plant. The construction of a desalination plant requires effective integration of mechanical and electrical devices and water quality instruments, as well as graphic control systems to achieve stabilized operation of the desalination mechanism and reliable process units. During the construction period, professional teams with different specialties were united and engineering quality was controlled via a comprehensive quality control program so that construction tasks were engineered to the specified quality requirements. On completion of each unit, test runs were carried out to ensure that the specified quality of the desalinated water was achieved. In the main process of the desalination plant, seawater is first led into intake wells via the 1-meter HDPE pipeline from the offshore intake header installed 320 meters south of the plant. Seawater is transferred from the intake wells to the pump room, where seawater pumps pump the raw water into the sedimentation tank, where large gravel is then separated out by sedimentation. The raw seawater, after sedimentation, is pumped to the self-cleaning filter, after which it passes through the UF system for further filtration before entering the filter tank. This UF system is the very first ultrafine filtration equipment in Taiwan, used as a pre-treatment for a desalination plant. The filtered water is then pumped to the high-pressure pump via a one-stage RO intake pump to ensure the filtered water entering the high-pressure pump is free of silt or any other impurities. A safety filter is installed in front of the high-pressure pump to protect it. After the filtered water passes through the safety filter, 40% is pumped out at a pressure of 60 to 65 kilograms per square centimeter. 60% is pumped out by energy recycling device and then recombined into the core unit of the desalination plant. The RO system, which has an output of about 40% desalinated water and 60% brine. The discharge pressure of the brine can be reclaimed via an energy recovery device and boosting pump to repump the filtered water so as to reduce energy consumption. A total of 6 RO units are installed in the Magong plant, producing a maximum of 15,250 tons of desalinated water a day. 2 RO units are installed in the Wang'an plant, with a daily production of 800 tons of desalinated water. Finally, the desalinated water enters a desalinated tank via a mineral tower and is then distributed to users via the city water mains. Furthermore, in order to ensure a steady yield of high-quality desalinated water, as well as the safety of users, the entire water production system is monitored and controlled by precision instruments. There is a comprehensive quality surveillance system in addition to a water quality analysis laboratory where desalinated water is tested regularly to ensure every water production sector is pollution-free. The power substations are equipped with quality power distribution devices to ensure the desalination plant gets a steady and satisfactory power supply. 60% of the water with high salt content processed by the desalination unit, known as the brine, is collected and further treated to meet the EPA's ocean effluent criteria before being discharged into the wastewater basin, where the wastewater is pumped by the effluent pump to the offshore diffuser, 1,200 meters away from the plant, via an HDPE discharge pipe, 900 centimeters in diameter, and then discharged into the sea. In addition to selecting a first-class desalination unit for providing a stable fresh water supply with improved quality, the project also aimed to protect the environment. The water production unit employs the most advanced energy recycling device in the world for effectively reducing energy consumption. The plant peripheral is also complete with streetlights powered by wind and solar energy. A sedimentation interception tank has been provided to reserve rainwater captured from the drainage of the plant area. Rainwater is settled to remove the sand. It overflows into the rainwater collection tank underneath the parking lot and is used as a water source for the spray irrigation system used for greening the entire plant. When we mention Penghu, we think of sunshine, sailboats, waves, and people playing in the sea. The plant is therefore designed with a large number of local characteristics, such as reproduction of traditional tribal villages with external walls decorated with traditional gables. Since Penghu has limited sources of architecture materials, it is vital that a traditional structure use local materials. That is why Laogu stone, a wall decoration using local stones, dominates the architecture of the plant. To convey the collective characteristics of leisure, romance, and the dynamic energy of Penghu, sails made of perforated plastic board were used to reveal the image of the brave who stood tall against the seas. However, the streamlining was gentle and smooth, suggesting a spirit that blends rigidity with softness, which fully complies with the island characteristics of Penghu. Trees are arranged in open spaces within the plant. Bushes fill in the spaces. Ground-covering plants are further used to cover any exposed soil, forming a three-dimensional plantation comprising high, medium, and low vegetation layers. Not only blending the plant with natural ecology by providing a habitat for insects, birds, and small wildlife, but also creating scenic landscaping within the plant. The plant also acts as a model that functions as a location for education, leisure, and sightseeing activities. The briefing room, equipped with audio-video facilities, provides first-time visitors with comprehensive knowledge of desalination procedures, as well as the importance of water resources. Observation platforms are provided so visitors can get a close-up view of the operation of the water production unit, with an emphasis on water conservation. Basketball courts, a multifunction plaza, and coastal walkways provide leisure activities other than plant tours for neighboring residents or tourists. Finally, the main function of the plant is to provide a stable water supply, improved water quality, in addition to employment opportunities for the community and multifunction spaces for education, leisure, and tourism activities. Most importantly, the plant serves as a reminder for us to cherish our water resources. Penghu lacks water resources, and water acquired by the natural hydraulic process is inadequate for meeting the demand. In addition to the expensive desalination project adopted by the government, thrifty water conservation with enhanced recycling and reuse of water is the only answer to the water scarcity problem. Thrifty water use and wastewater recycling not only compensate for the deficiency of water sources, but also helps to cope with droughts or emergency shortages so as to mitigate inconvenience. Effective and continuous recycling of water ensures sustained development of our society and economy.